Hello everyone! So in today's video, we will be discussing integration by rationalizing substitution. So basically, rationalizing substitutions is just to transform some types of integrals which involves rational functions. So we have here an example. Evaluate integral of square root of x dx all over 1 plus x. So basically, in our integrand, it involves a rational function. So to solve this kind of problem, we can let any variable so that we can solve this one easily. So meaning to say, we can let u as equivalent to square root of x. Now to find the value of our x, we also need, we can just square this both sides. So we have u squared is equal to x. Now we already have the value for x. Now we also need to find the value for our dx. So deriving this one, we have dx is equivalent to 2u, then the du. And then afterwards, as you can see, we already got the values that we will be needing for the substitution to our integrand. We can already proceed with our substitution. Now, square root of x can be replaced by our u here, and then for the dx, we can replace that one by 2u du. So I have it here. Then that is divided by 1 plus our x can be replaced by u squared. So simplifying our integrand, 2 is constant, so we can put that outside. Now u times u, that is u squared du all over our binomial, which is 1 plus u squared. Now, as you can see, this one is this one is quite hard to integrate, so we need to simplify this one first by doing or by applying long division of polynomials. So basically, we can just interchange this one, so we can have u squared. We can have it as u squared plus 1 divided by u squared. So afterwards, u squared divided by u squared, that is 1. 1 times u squared, that is u squared. 1 times 1, that is positive 1. So this is 0. Now 0 minus positive 1, that is negative 1. So basically, this is now our remainder since we cannot divide it by u squared anymore. So in writing our remainder, we just have to subtract it by our quotient, over 1, and then we have to divide it by our u squared plus 1. So meaning to say, this quotient here, it can be replaced instead of u squared over all over 1 plus u squared. So meaning to say, we have 2, and then integral of 1 minus 1 all over u squared plus 1. Then we have our du. So afterwards, we can already proceed with our integration for this one. Now separating our integrand, we have 2, and then the square root of du minus 2, and then the integrand du over u squared plus 1. So integral of 2 du is equivalent to 2u minus for this one. Since this is squared, so meaning to say we cannot have this as our u, our denominator can't be our u since our variable here has a power. So if you can remember, for our inverse trigonometric integral, we have u squared plus 1 squared, right? So this one is equivalent to 1 over a arctan of u over a plus c. So meaning to say, our u here is equivalent to u, and our a is equivalent to 1. So meaning to say, we can write it as 1 over a, in which our a is 1, arctan of u, in which our u is equivalent to u, and we have our a as 1, and we have the plus c. So rewriting this one, simplifying this one, we have 2u minus 2 arctan of u plus c. Now, we have to replace our uh, value, our variable, by its original value, in which our u is equivalent to square root of x. So meaning to say, we also have to return it back to its original value. So meaning to say, we have 2 square root of x minus 2 arctan of square root of x plus c. So this is now our final answer. So I will also be pasting here the much clearer solution for our problem. So we have it here as this one. So we have here another example, which is to evaluate integral of dx all over square root of x plus cube root of x. So as we know, this can also be written as dx all over x raised to 1/2 and x raised to 1/3. Now, as you can see, we have two radical expressions in this integrand. So in solving this kind of problem, we have to identify our exponents of our variable, in which in this case, we have 1/2 and 1/3. So since we are substituting another variable to our expression, so meaning to say, to find the value that we will be substituting, we need to find the least common multiple of our denominator of the exponent. So that being said, the least common multiple of this exponents, or this fraction, is equivalent to 6, right? 2, the least common multiple of 2 and 3 is 6, meaning to say our x can be substituted by u raised to 6. So now we will be substituting our x by u raised to 6. But we have to find our derivative of x also to so that we can substitute it in our numerator. So dx now is equivalent to 6u raised to 5 du. So meaning to say, this dx here can be replaced by 6u raised to 5 du. And that is divided by our x raised to 1/2. In this case, our x is substituted by u raised to 6. So meaning to say, we have u raised to 6 times 1/2 plus u raised to 6 raised to 1/3. So 6 here is a constant number, so we can put that outside our integral symbol. So we have here u raised to 5 du, and then u raised to 6 raised to 1/2, that is equivalent to u raised to cube. And for this one, u raised to 6 times 1/3, that is u raised to 2, or u squared. Then afterwards, as you know, there is a common term for our denominator. So meaning to say, we can factor that common so that we can see if we can cancel some terms afterwards. So we have u raised to 5 du. And then again, we have a common term here, which is u squared. So meaning to say we have u plus 1. So as you can see, this is u raised to 5, so we can cancel this one and cancel this one. So we have 6 integral of u cubed du all over u plus 1. So afterwards, we can already simplify this one by applying long division of polynomials. So we have u plus 1 divided by u cubed. So u cubed divided by u, that is u squared. U squared times u, that is u cubed. U squared times 1, that is positive u squared. So we have 0, this is 0, and then 0 minus positive u squared, that is negative u squared. Then negative u squared times divided by u, so we have negative u. And then negative u times u, so we have negative u squared. Negative u times 1, that is negative u. So meaning to say this is 0, now 0 minus negative u, that is positive u. This can still be divided by our u, so meaning to say u divided by u, that is plus 1. So we have here plus 1. 1 times u, we have u. 1 times 1, that is positive 1. So we have negative 1. Negative 1 cannot be divided anymore. So meaning to say this is our remainder. Again, in writing our remainder, we have minus 1 all over u plus 1. So meaning to say this quotient now can be, we can replace this one now in our function here. So that being said, we can rewrite our function as equivalent to 6, and then the integral of this one, which is u squared minus u plus 1 minus 1 all over u plus 1, and then we have our du. So we can already integrate this one separately. So we have 6 times integral of u squared du minus 6 integral of u du plus 6 integral of du, that's du, minus 6 times integral of du over u plus 1. So as you can see, this can be integrated easily. So we have 6u cubed over 3 minus 6u squared over 2 plus 6u minus, for this one, we can let this one as our u. So if this is our u, the derivative of our u is the du. So I mean to say this is our du. So that can be written as negative 6 ln of u plus 1 plus our c. Now, this is already our result. However, we need to transform our variable back to its original value, in which that is, we need to find again the value of our u so that we can replace it to our original variable. So as you can see here, from this equation, we can find the value of our u. So if we multiply both sides by 1 over 6 raised to 1 over 6, meaning to say our u now is equivalent to x raised to 1 over 6. So meaning to say we can substitute our u here by x raised to 1 over 6. So 6 divided by 3, that is 2. And then change our u by x raised to 1 over 6 cubed. And then we have 6 divided by 2, we have 3. Changing our u by x raised to 1 over 6. Then we have the squared plus 6 x raised to 1 over 6 minus 6 ln of x raised to 1 over 6 plus 1 plus our c. Now simplifying our answer, we have 2x raised to 1/2 minus 3x raised to 1/3 plus 6x raised to 1 over 6 minus 6 ln of x raised to 1 over 6 plus 1 plus our c. And this can also be written as 2 square root of x minus 3 cube root of x plus our 6x raised to 1 over 6 minus 6 of ln of x raised to 1 raised to 1 over 6 plus 1 plus c. So basically, this is now our final answer. So I'll also be pasting here the much clearer or visible solution of this problem. So we have it here. So that's it for this example. So we have here another example, which is to evaluate integral of square root of t dt all over 2 plus 4th root of t. So now, in this case, we can also rewrite this one as equivalent to t raised to 1/2 all over 2 plus t raised to 1/4 dt. So as you can see, the exponents or the powers of our variable is different, meaning to say we have to follow the same process as the previous example, meaning to say we have to find the LCM of our of the denominator of our exponents, in which in this case our exponents are 1/2 and 1/4, meaning to say we have to find the LCM of our denominator. So in this case, the LCM of our denominator, the LCM of our 2 and 4 is equivalent to 4, right? So meaning to say, we can substitute our t as equivalent to u raised to our LCM, which is 4. Now, we already have the value for t, however, we still have to find the value of our dt. So in this case, if we derive this one, our dt is equivalent to 4u cubed du. So we already have the values that we will be needing for the substitution. So proceeding with our substitution, our t is equivalent to u raised to 4. So meaning to say, we have u raised to 4 multiplied by 1/2 all over 2 plus our u raised to 4 raised to 1/4, and our dt is equivalent to 4u cubed du. Since 4 is constant, meaning to say we can put that outside our integral symbol. So we have the integral of u raised to 4 times 1/2. So meaning to say we have u squared, then we have the u cubed left here, then we have the du all over our denominator, which is 2 plus u raised to 4 times 1/4, that is just u. So from this one we have 4, then u squared times u cubed, that is equivalent to u raised to 5, since we just have to add the exponents because it has the same base. Then we have the 2 plus u. So for this one, we can still simplify our polynomial here by applying the long division of polynomials. So that being said, we can have u plus 2 divided by our u raised to 5. So u raised to 5 divided by u, that is u raised to 4. U raised to 4 times u, that is u raised to 5. Then u raised to 4 times 2, we have positive 2u raised to 4. Then we have, this is u raised to 5 minus u raised to 5, that is 0. 0 minus 2u raised to 4, that is negative 2u raised to 4. Now we can still divide it by our u. So meaning to say we have negative 2u cubed. So negative 2u cubed multiplied by our u, we have 2u raised to 4. And then negative 2 times 2, we have negative 4u cubed. So this one is 0. So we have positive 4u cubed. 4u cubed divided by u, we have positive 4u squared. 4u squared times u, that is 4u cubed. And then we have 4u squared times 2, we have positive 8u squared. Then for this one, we have negative 8u squared, in which this can still be divided by u. So we have negative 8u. Negative 8u times u, we have negative 8u squared. Then we have negative 8u times 2, we have negative 16u. So we have positive 16u. Now again, 16u can still be divided by u, in which it is equivalent to positive 16. 16 times u, we have positive 16u. 16 times 2, we have positive 32. So meaning to say we have negative 32 as our remainder. So as you can see, this can't be divided by our u anymore. So meaning to say we have to write it together with our quotient. So we have 32 over u plus 2. So meaning to say we can replace this one by our polynomial. So we can also rewrite this one as equivalent to 4 integral of u raised to 4 minus 2u cubed plus 4u squared minus 8u plus 16 minus 32 all over u plus 2, and then we have our du. So afterwards, we can already integrate this one separately. So we have integral of 4 square root of u, integral of u raised to 4 du minus 4 times 2, that's 8, integral of u cubed du plus 4 times 4, we have 16, integral of u squared du Then we have the 4 times 8. We have negative 32 integral of u du plus 4 times 16. We have 64 integral of du minus 32 times 4. We have 128 integral of du over u plus 2. So afterwards, we can already integrate this one using power formula or using applicable integration. So we have 4u raised to 5 all over 5 minus 8 raised to 4 over 4 plus 16 u cubed all over cube or 3 minus our 32 u squared all over 2 plus our 64 u minus 128. And for this one, we can have this as our u and this is our du. So meaning to say we have ln of u plus 2 plus c. So afterwards, we can still simplify this one. But before we simplify that one, we have to find the value of our u. So, we have to find the original value of our u so that we can replace it to its original variable. So, meaning to say, from here, we can get the value of our u, or we can isolate u by multiplying both sides by raised to power of 1/4. So meaning to say our u now is equivalent to t raised to 1/4, or the fourth root of our t. So basically we can rewrite our u here as equivalent to t raised to 1/4. So that being said, we'll rewrite this one as 4 over 5 times t raised to 1/4 multiplied by 5 minus 8 divided by 4, that is 2. And then we have our t raised to 1/4 raised to 4 plus 16 over 3 times t raised to 1/4 cubed minus 32 divided by 2, that is 16, and then we have our t raised to 1/4 squared plus 64 times our t raised to 1/4 minus 128 ln of t raised to 1/4 plus 2 plus our c. So again, we can still simplify this one. So we have 4 over 5 t raised to 5 over 4 minus 2 t, since 1/4 times 4, that is equivalent to 4, plus 16 over 3 t raised to 3/4 minus 16 t raised to 1/2 plus 64 t raised to 1/4 minus 128 ln of t raised to 1/4 plus 2 plus our c. So basically, this is now our final answer for our problem. So I'll also be pasting here the much visible and much clearer solution of our problem. So we have here. So I hope you learned something from our discussion for this video, and I hope to see you on my next video. Please don't forget to like and subscribe. And thank you so much for watching. Goodbye.